Okay, so from the first week, we know about variables and values and loops. From the previous section, we talked about decisions, if, elif, else, and various relational and equality and identity operators. In this section, we're going to take a look at how to combine the things that we know to create programs that we can run. Our programs are also going to be able to read input from the user, and in order to make use of the input that the user types, we have to talk about what's called type conversion, because any input that the user types on the keyboard is going to come in as a string, but often we need to use that string as a number to be able to do some kind of computation with it. Okay. So we know about variables, we know how to do arithmetic, we know how to define sequences or collections of values, such as stir and list. We have a way of looping through items with the for loop. We have a way of making decision with if, elif, else. So we finally know enough to be able to write useful programs. Okay, so most programs of small to medium size have a fairly simple top-level structure. They read some information from someplace, some data. They process or analyze that information in some useful way, and then they produce some output for some user or users to look at. In fact, the HIPPO or HIPO acronym, which stands for Hierarchical Input Process Output, was one of the very earliest so-called top-down software design methodologies. And even though this is an old idea, it's still useful in modern programs, at least of small to medium size. Any kind of methodology, that is, any kind of plan of attack for developing software, is certainly better than just kind of floundering around trying to figure out what to do on an ad hoc basis. All right, so this will be how we're going to organize our programs. We're going to get some data, we're going to process the data, and we're going to produce some output. Now, where do we get data from? Well, we're going to start out by taking a look at how to get data from a user's keyboard. Then we're going to move on to talk about how to get data from a file on the user's disk drive. We can also get data from a website out on the internet. If we're doing hardware control kind of software development, which we're not in here, we might have a sensor like a temperature sensor or wind speed sensor or barometric pressure sensor or something like that hooked up to our system that we can read data from. Those are just some examples of where we might get data from. For getting input from a user, Python provides a handy function called input, which reads a line of input from the user up to when the user presses the enter key. And what input does is to return a stir, that is a string, containing that line of information that the user typed. Now, normally, the input function is called with a prompt string as its argument. The input function will display that prompt string and then sit and patiently wait for the user to type some input. When the user eventually presses the enter key, the input function will gather that line of text that the user typed and return that as a string. But the new line character itself at the end of the line is stripped out from that string. So the new line character is not included. Let's take a look at an example of this. So I'm going to say input stuff. this is a very bare bones and not very useful example, but I'm going to say input stuff, and the input function displays its string argument as a prompt. I'm going to say hello input as my line of text. So I've typed HELLO space INPUT. Now I'm going to press the enter key. And what the input function returns, which is then immediately displayed by the shell, is the string hello space input. And notice that there is no \n at the conclusion of this string, because the enter key that I typed is not included as part of the string. Now, what we did there was not very useful, because the minute the input function returns, what it returned is displayed on the screen, but then it's vanished into thin air, so to speak. So let's assign the result that the input function returns to a variable so that we can make use of that variable. Let's say s gets input, and we'll give a somewhat better prompt here. Type stuff and press enter. I typed this space character here between the colon and the quote intentionally, because when the input function displays its prompt, I actually want for beautiful for beautification purposes, for formatting purposes, to display a space following that colon. Notice when I gave stuff and a colon as my prompt, I just got stuff and a colon displayed, and users sometimes find it a little awkward to have to start typing stuff right after the, well, it's not awkward, it just isn't very nice looking. So I've put a space in there intentionally, and here's my prompt. Type stuff and press enter, colon space. I'm just going to say hello with an exclamation mark. S now contains hello and an exclamation mark. The new line character that I got when I pressed enter is not included as part of the string that S refers to. Let me pass S to the print function like so. I'm going to say print S has length len S. And the output of print is hello has length 6. So Shazam, this is a program. We have gotten some input from the user. We have done something with that input. We've analyzed it, for example, by computing its length. And then we have used print to display some output of interest to the user. Now the user here must have a very high tolerance for boring information, because there's nothing very exciting about hello has length 6. But this is the overall structure of many simple and medium-sized programs. Input, processing, output. All right, so we've read some input using the input function. We set up the variable s to refer to that input. We then processed the input by computing the length, and we displayed output by using the print function. It's not very interesting to type this kind of stuff in interactively, because now that code is no longer available for me to reuse in the future. So let us, in idle, create a new file. This will be a new program file, and the editor window is pretty big by default, so let me shrink it down a little bit. All right, so now we can see, we can see the editor window. Okay, so now we can see the editor window in our viewing area for the video. And I'm going to type this in as a program. I'm going to call this thing, I'll say File, Save As, and in my directory for this course, which is somewhere, come here, there we go, Introduction to Programming with Python, Online 2020, there we go, that directory. And I'm going to call this thing IPO1. That is Input Processing Output Program number 1. My editor will automatically add a .py extension, so the name of this file will be ipo1.py. And if you squint, you might be able to see that on my screen here. Now, it's always a good idea when you write a program to have comments at the top describing some characteristics of the program. So I'm going to put in that this file name is ipo1.py, and I'm also going to put in that the author of this program is me. You might also put in some description, some brief overall description of what the program is doing, etc. Once I've got that commentary, those comments typed in, I can then put in my code. S gets input, type stuff, and press enter. And print S has length len of S. Whoop. There we go. All right, so that's my program. I'm going to say file, file, save. And once I've saved it, I can say run module. And there we go. So input has been called. Type stuff and press enter. This is a test. And I get told this is a test, has length 14. Make sense? Okay, we've got 4, 8, 12, and then these two spaces here gets us to 14 characters. Now, the result that we get back from input is always a string. And there are many contexts where we can't really use a string directly. Let's suppose I say feet string, ftstr, gets input, enter your height in feet. Now, I happen to use double quotes to contain the string here. Since I do a lot of programming in other languages, I sometimes automatically use double quotes. But either single quotes or double quotes works, obviously. Enter your height in feet. Well, I'm not quite 6 feet high, so let's just say 5.9 here. And now I'm going to say print in inches, I am ftstr times 12 inches. And I'm hoping to get 12 times 5.9. Okay, well, my problem here is that footstr is a string, not a floating point number. In fact, if I ask to see the type of footstring, I get told that that thing is a string. And consequently, this multiply operator here, the star operator, is being treated as the repetition operator, repeating footstring 12 times. So I've got 5.9 once, 5.9 a second time, 5.9, 5.9 a third time, and then a fourth time and a fifth time. And if you count all the way through, you'll see that this is, technically speaking, this is correct, because it is footstr repeated 12 times. But it's not what I was hoping for. I really want to get the value 5.9 multiplied by 12 to get the number of inches tall that I am. We can convert a string into a float and store that result into a variable by using the type float as a conversion function, or a construction function if you like. So footster here is, let's confirm, before I do that, let's confirm that footster is the string 5.9. So it's a 3-character string. But if I say feet gets float of footster, that converts that string into the corresponding floating point value. All right, so feet is the floating point value 5.9. And now I can say print inches feet times 12. And I get told that I am, this is not exactly right, but it's close, 70.8 inches tall. Now, because of the fact that a floating point number can only be represented out to a finite number of digits, I do have a stray bit of garbage out here. This 1 is really just garbage hanging off the end of this value. And it would be nice if I just got a 70.8 or a 70.80 instead of all these zeros and this garbage 1. We'll talk later about how we can more cleanly format the output that we get from a print function call. So, what's the deal here? So, we ask the user for some input. We get some input with, we read the input. We're then going to convert that input, which is always a string from the input function, into a type of value that we can use for arithmetic. And most commonly, that's probably a float. Then we will do our arithmetic if we need to do arithmetic, and then we'll produce some output. And here is my feet to inches program. Let's go ahead and let's go ahead and type this guy in. Whoops, that's an old program there. Let's, all right, so here's my IPO1 program. Let me make sure this has been saved. And now I'm going to save this as, what I'm doing save as because I don't want to have to wrestle with resizing an editing window. I could just say File, New File, but then I'd have to wrestle with resizing the window. So instead, I'm going to say File, Save As. And what I want now is a program whose name is feet to inches. And let me change the name of the file, feet to inch, and change the code. So footster is input, enter height in feet. Then, because I know I'm going to get a string back, but I want to do arithmetic with the value, I'm going to convert that footstring value into a float. And then I will print out inches feet times 12. All right, now I'll save this and run it. Run module. Enter height in feet. Let's pretend I'm taller, 6.5. I'm almost a basketball player. 6.5 feet is 78 inches. And in this case, there was no stray garbage at the tail end, so I just get the default format for a float, which is 78 point, and then in this case, just 1 0 of output. Now, in general, you can use type names like float int stir bool to convert values in one data type to values of a different data type. And without getting into the nitpicky details, I'm just going to say that this works within reason. That is, if you think it ought to work, it probably will work. And if you think it shouldn't work, it probably won't work. So if I say int 4.567, it is valid to convert a float value into an int. What happens, though, might be a little bit different from what you expect. You might look at that value, 4.567, and say, gee, that's closest to the integer 5. What I get, though, is a 4 because the fraction part is truncated. That is, it's just chopped off, no matter how big it is. So if I say int of 4.999999, that's still going to be 4. Same thing goes for negative values. If I say minus 4.99999, once again, the fraction part is simply chopped off. And my integer conversion from minus 4.9999 is minus 4. I can convert a string to an integer. So here I have a string of 3 characters, 4, 5, and 6. And if I convert that to an int, I get the value, the int value, 456. I can even convert a Boolean value, either true or false, into an int. And by convention in Python, the rule in Python is that true gets converted to the integer value 1, whereas false gets converted to the integer value 0. We already saw one example of converting from a string to a float. We had, what did I claim, 5.9 feet, okay, by typing in the characters 5.9 and then enter on my keyboard. When we convert that string into a float, we get floating point 5.9, which we can successfully do arithmetic with. Now, converting an integer to a float works as long as the integer is not too enormous. So converting the integer 123 to a float works fine, and I get 123.0 represented as a 64-bit floating point number. I run into trouble if the integer that I'm trying to convert has more than about 16 digits in it, however. So if I type float with this long sequence of ones, that will actually fit within the range for a float. It ends up being 1.11111 times 10 to the 42nd power. But most of these trailing ones are chopped off and thrown away. I don't have that amount of precision in my resulting float value. In fact, I may have an int that's so large that it can't fit into a float at all. If I say something like float of, and then I just hold down some character for a few hundred characters, I'm going to end up with an integer whose magnitude will not fit into a float either. All right, so I'm guessing there are about 70 characters per line here, and I've typed, looks like 7 lines. So that's going to be about 490 characters, roughly speaking, which would mean that value is around 10 to the 490th power or so. And I get told that this int is too large to convert into a float at all. So that conversion is going to fail. All right, so we've taken a look at converting things to ints. We've taken a look at converting things to floats. Now, converting things to bool is interesting. It turns out that where numbers are concerned, any non-zero value converts to true. And it doesn't matter how tiny or how big that non-zero value is. Any zero value, whether it's an int or a float, converts to false. For that matter, if you convert an empty string into a bool, here I've written an empty string by just having two single quotes right next to each other. An empty string is treated in Boolean as false, whereas any string that contains any characters is true, even if the character is a blank character. Now, here I have a string containing just a single space character, and it might not be totally clear when you just look at the screen here what the difference is between quote quote and quote space quote. But the difference is that quote quote is an empty string, whereas quote space quote is a string that has a character in it. And consequently, if I treat that as a bool, it's true. Any kind of value at all can be converted into a string. So I can ask to convert none into a string, and I just get a string containing none. I can convert this floating point number, 12.354 times 10 to the 8th power, into a string. Now, for this string conversion, the string data types conversion function notices that that number is not actually terribly large. So to make it easier for the user to read, the string conversion is going to throw away that exponent part and just fill in enough zeros to give me a proper floating point representation. If the exponent is too large, 10 to the 300, let's say, then the conversion will preserve the exponent rather than trying to expand out to 300 zeros. That's just an internal choice that conversion makes. Okay. Well, so that gets us to the end of our first look at writing a useful program. That is, most small to medium-sized programs simply get some input from somewhere. In our case, we illustrated how to get input from a user. Then the program analyzes or processes that information in some fashion, and finally produces some output for a user to look at. Often, when you're getting input from a user, if you want to do things like arithmetic with what the user typed, you're going to have to convert from the string data type into a numeric data type. Usually you do a conversion to a float. Okay, so you'll get a little practice with this in Lab 2.3.